Oh my gosh. Okay, so this is an example of the kind where they tell you the force, the downward force of 4.01 newtons on the mass at the top, right? And so I think what we do, let's just see what we do here. I think what we do is we actually have to start with, I mean, first off, we're going to figure out the weight of this thing, right? So our mass is 2.72 kilograms, right? The radius is 1.95 meters. And then at the top, the force at the top is 4.101 newtons down. So let's figure out the weight first, just for fun. It is 2.72 times 9.81. Okay, so 2.72 times 9.81. That is 26.6832. 26.38. That's not right. 26.6832. Dyslexics should not be teachers. Okay. Or maybe they should be. Okay, so that is newtons. That's the force of gravity. Okay. Okay, what do we do now? Oh, I know what we do. So let's start at the top. They tell us about the top, right? They tell us this story here. So let's set that guy up, right? Now instead of an unknown force, we've got a known force, right? So we say, okay, a downward force of 4.01. And everybody forgets that, right? But because it's downward, right, that means that this is actually a negative force, right? And then, of course, the gravity is also down, right? The 26.6832. Okay. And those are our two forces, and then that equals 2.72 times A, and we don't know what A is. Ooh, we can do this. Okay. So this, and then we add the 4.01 to it, and then we divide by 2.72. And I get a negative 11.28. meters per second squared. Okay, that's roughly 11.3, right? Okay. Okay, so now we've got that. Then what does it say? What is its period of motion? I was hoping you wouldn't ask that. Okay, so to find period, we're going to use this guy here, right? A is equal to 4 pi squared r over t squared, right? And then if we want to solve that for the period is going to be what the square root of, because it's squared, right? I put that up there, put the a down here, right? And I get 4 pi squared r over a, and then the square root of that, right? Okay. So ultimately that's going to be the square root of 2 pi, the square root of r over a. So what's r? R is 1.95 meters, right? Right, and then the acceleration is 11.28. Okay, I think let's try that. Okay, so let's go 2 pi times the square root of r, 1.95. Divided by 11.28. I get 2.61 seconds. Okay. I don't have any room. We'll put it up here. We'll save this space right here. 2.61 seconds. And that's, of course, what we get here, right? Okay, so that's typically what these questions ask you for, is that they'll ask you for some other thing about it, right? So we've got to find that. So we got that. And then we got to find the force at the bottom. Okay, so now at the bottom, we don't know the force, right? The weight is still 26.6832. Right, and then we go 2.72, and then we just use this acceleration. Only at the bottom we're accelerating up. At the top it was a downward acceleration because it was centripetal, right? But at the bottom it's positive, so we go positive 11.28, and now we're set, right? Okay, so 2.72 times 11.28 plus this guy, right? Plus 26.6832. And I get 57.36. So 57.4 newtons. And that, because it's positive, it means that it's up, right? All right. Wow, am I done yet? I think I am.